A greenhouse can have an acceptable thermostat reading above the aisle while the crop canopy is sitting in a hot, humid, nearly motionless layer. Ventilation succeeds only when the right air reaches the plant zone, carries away heat and moisture, and exits through a controlled path under both day and night conditions. Start by defining what the crop needs. Temperature, relative humidity or vapor pressure deficit targets, carbon dioxide strategy, leaf wetness risk and acceptable air movement depend on the crop, growth stage, disease strategy and production method. The goal is not the highest possible fan airflow. It is a stable plant zone environment without damaging drafts or stagnant pockets. Now map the loads. Solar radiation can make a greenhouse a heat trap. Plants and wet surfaces add moisture through transpiration and evaporation. Lights and equipment add heat in a grow room. Outdoor temperature, humidity, wind, and solar position change through the day. At night, the sensible heat load can fall while surface cooling raises condensation risk. One operating mode cannot solve every state. Different devices perform different jobs. Roof and side vents can provide natural ventilation. Exhaust fans and controlled inlets exchange indoor and outdoor air. Horizontal airflow or circulation fans mix the space and reduce local layers, but do not automatically remove moisture from the building. Fan and pad systems combine air exchange with evaporative cooling, whose performance depends strongly on outdoor humidity. Dehumidification and heating may be part of another control path. For mechanical exhaust, trace the full route. Outside air enters through the intended shutters, travels across and through the crop zone, picks up heat and moisture, and leaves through the exhaust bank. If an inlet sits too close to a fan, air can short-circuit above the crop. If inlet area is inadequate, static pressure rises and delivered airflow falls. Uniform distribution matters as much as total volume. This real Longwell AC axial fan shows a common high-volume, relatively low-pressure architecture. The product footage confirms physical size, blade and housing construction only. It is not a greenhouse installation and does not prove a project duty. Greenhouses may use axial, centrifugal, circulation or mixed equipment depending on resistance, layout, exposure, control and service needs. Select the exhaust fan against the installed pressure path. Shutters, guards, insect screens, evaporative pads, filters, louvers and weather hoods all add resistance. A free air number or fan diameter is not enough. Compare tested airflow, pressure, electrical input, sound, speed range and efficiency at the expected clean and loaded conditions, then reserve access for cleaning and replacement. Circulation placement needs its own map. Build a gentle loop above and through the canopy, connect the ends of the house, and inspect corners, benches, hanging crops, and obstructions. More fans do not guarantee better mixing if they fight one another or aim directly at sensitive plants. Use smoke, ribbons, anemometers or other agreed checks to find stagnant and over-velocity zones. Controls must change with time and weather. A bright summer day may require staged exhaust, large inlet opening, shading or evaporative cooling. A cool night may need low exchange, circulation, heat or dehumidification to manage condensation. Winter minimum ventilation must remove moisture without creating harmful cold jets. Write these states before choosing the fan quantity and speed range. Sensor placement should represent the crop, not just the control cabinet. Use shielded and maintained temperature and humidity sensors at meaningful canopy locations, plus outdoor conditions and any required carbon dioxide or leaf surface measurements. Define fan stages or variable speed commands, inlet position, vent and pad interlocks, alarm delays, sensor failure behavior and recovery after power loss. Commission and maintain the entire system. Confirm fan rotation, shutter travel, inlet opening, measured static pressure, current, airflow distribution and the response of every control stage. Recheck dirty screens, pad loading, loose belts where applicable, blocked guards, corrosion and a fan-out condition. A failed shutter can become an uncontrolled inlet and disturb the whole pressure pattern even when other fans still run. For a greenhouse ventilation review, send the structure dimensions, crop and canopy layout, day and night environmental targets, solar and equipment loads, outdoor design conditions, required ventilation modes, inlet and exhaust locations, pads or screens, installed resistance, voltage, controls, sound constraints and maintenance access. Then circulation, exhaust, intake and cooling can be designed as one system. For a project-specific review, visit longwellfans.com/contact.